We are solving ISS 2022 paper 3 question number 6C. So describe the cluster sampling, so you can define that and state the sampling variance of the unbiased estimator of the population mean in terms of intra-cluster correlation. Okay, so I'm not gonna do the proof part. So this is the estimated in case of cluster sampling, and this is the variance of the cluster sampling, and for large n this variance can also be written like this. Okay, and where rho is the intra-class correlation. Okay, intra-cluster correlation. So this is the first one that you need to do. So for the proof of this, if you do not know, then you can look at the sub notes. Okay, chapter number 9. Okay, so you can see in chapter number 9 it is the proof is given here. Okay, now coming on to the second part. So a survey is carried out from a simple random sample of 90 clusters. Okay, so and each of 40 households. So a simple random sample is of 90 clusters, means number of clusters is 90, and each of 40 households, and the cluster size is 40. Okay, and the cluster are selected using simple random sampling at a rate f is equal to 1 by 300. Okay, and then to improve accuracy of the result, okay, a statistician proposes to reduce by half the size of the clusters. Okay, so to improve the accuracy, a statistician what did is that he half the size of the clusters, means our earlier size was 40, so our new size will be, suppose let's denote it by m1 and with the n1. So our new size is half, means 40 by 2 is 20. Now read further. A statistician proposes to reduce by half the size of the clusters by selecting twice as many of them. Okay, so he half the size of the cluster and he selected the twice of the units. Okay, means suppose we selected n1 units in n1 units earlier, then we are selecting 2 of n1. Okay, means this is n2, you can write like this. Okay, so we are selecting twice of n1 unit in the second way. Okay, so but recall that in a cluster sampling, okay, so there are n clusters, each of size capital M. So if we half, okay, if we half the clusters like this, okay, then you can see that the one cluster is separated into 2, means number of clusters is twice. Okay, so in that case number of clusters will be twice, so n2 will be 90 into 2, means 180. Okay, so this is the information that is given. Now what we need to do, that show that the relative efficiency is this. So efficiency is basically the ratio of the two variances. Okay, so we need to show that the relative efficiency is this, assuming intra-cluster correlation which is rho. Okay, so that we have proved this formula in the first part, and other quantities do not change. Okay, so we need to find the relative efficiency, means variance of y bar, okay, and variance of y bar in the first case and in the second case. Okay, so let's write 2 by 1. Okay, so for now let's write this formula. So variance of the estimator under second case, which is this, will be s square. Now look it for the s square. What is s square? S square is the population variance. It is defined like 1 by, now note that there are capital NM units in the population, NM. So according to the definition, s square will be I from 1 to n, j from 1 to m, yij minus capital Y bar square. Now capital NM will be constant in both the cases. See, 90 into 40, 3600. Similarly 180 into 20 will be 3600. So this will be constant, okay. And Yij for nm quantities will be same, okay. And what happened with the capital Y bar? Capital Y bar is the total number of unit is nm, and Yij double summation I from 1 to m, j from 1 to m. So this will also be same for both the situations. So our S square will be remain same in both the situations, okay. That is I want to point out. So also I have written that other quantities do not change. So so when we take the ratio of this, so our expression will be like 1 by n1. S square won't change, so S square will be, we will be denoting as like as it is now, m2 1 plus m 2 minus 1 into rho divided by 1 by n1 m1 S square 1 plus m1 minus 1 rho. Now S square will cancel out. Now put all the values that we have noted here. So n2 is so let's n1 will be in the numerator, and n2 m2. Now 1 plus m2 minus 1 rho, 1 plus m1 minus rho. Now so n1 is n1 and m1 is 40. n2 is 2n1, put it here. m2 is 40, m2 is 20, okay. And 1 plus m2 is 40, so 40 minus 1 39, and this will be 20 minus 1 means 19 into rho. So now 20 into 2 40 means this will cancel out whole, n1 and will also cancel out. So 1 plus 39 rho, 1 plus 19 rho. So this is what we need to prove, okay. So actually I have done the reverse. So we should take variance of y1 divided by variance of y2 in this way. So we will be getting this answer, okay. So this is how you should solve this question.